In this lecture and in next few lectures, we'll discuss some important features of Python programming language. Understanding these lectures doesn't require any previous knowledge of programming. While Python is a feature-rich language, we'll focus only on the tools that will help us to start programming for scientific computing or numerical methods. Like many other skills, programming skill improves with painstaking practice, and programming skills improve rather slowly. Therefore, our focus here is to learn the absolute basics of Python programming to get ourselves started in scientific computing. In this lecture, we'll learn to write our first program, that is the Hello World program in Python. We'll also have some idea about string data type and Python function. Python comes in two varieties: Python 2, the older one, and Python 3, the newer one. In this course, we'll only use Python 3. In these days, knowledge of computer programming and specifically the knowledge of scientific computing is absolutely essential in all branches of science and engineering. In this course, we'll learn how to write programs related to scientific computing. I would like to convey two main points here. First, although I may conduct tutorials and give examples in Python, for you, it is not necessary to write programs in Python. You may use any programming language of your choice. Second, although writing program is very much necessary to learn the course materials and apply them in realistic applications, programming is not included in exams. Scientific programming requires time and patience. Scientific programming skill is difficult to test in our typical exam setup. Now that we have decided to use Python in this course, we have two ways to use Python for our purpose. We may install Python in our local machine, or we may use cloud-based Python where we won't have to install anything. For local installation, we may visit python.org or anaconda.com and download necessary installers. Anaconda also has a minimalistic version known as Miniconda. We may use that too. Python.org contains the main Python website and repositories. However, for scientific computing, we sometimes need additional Python packages. Anaconda gives us standard Python along with large number of Python packages that are useful for scientific computing, especially for machine learning and data science application. Anaconda is particularly optimized for machine learning and data science. And thus, Anaconda also contains additional languages and packages other than Python. If you wish to avoid such large installation of Anaconda, you may have a minimalistic version of Anaconda, which is Miniconda, which I intend to use in this course. If you are new to Python, I'll of course suggest you to use standard Anaconda. Once we install Anaconda in our local machine, we have three ways to write and run programs. First, we may use any standard text editor such as Notepad or Notepad++ or Programmer's Notepad to write our code, and then we can run the code from usual command prompt. Our second option is that we can use a standard IDE, that is integrated development environment, such as Spider or VS Code. In IDEs, we can write and debug code and then run the code within the IDE without using a command prompt. Third, we can use an interactive Python or IPython cell in Jupyter Notebook or in Jupyter Lab. This is the option I will use. The advantage of Jupyter Lab is that You keep your code, result, and text together, making it easier for us to learn. I'll give you an example shortly. For using Python in cloud, the best option is Google Colab. Anaconda also has its own cloud-based interface. Once we visit the respective Colab or Anaconda site and log in after creating an account, a Jupyter Lab type interface will open up and we'll follow the similar procedure of writing and running codes as we do in standard Jupyter Lab. Let us now visit the websites to check the details for ourselves. You can now pause the video and install Python or Anaconda in your local machine, or go to the cloud sites and get ready for our first program. Here we are at the python.org website. This is the main website for all Python assets. You can see there is a download button, and from here you can download Python for the operating system. This computer has a Windows operating system, so it is showing the version of Python for Windows operating system. You can download Python from here. You can also download the source code. Python is an entirely open source program. You also see that there is an interactive cell here. So some small Python codes you can run here and you can check the results. So for instance, if I click this, then you can see that Python cell is opening up, and here it is showing something that I have done before. So here if I write this 2 plus 3, then it gives me 5. And small calculations like this, you can do it here. 2 and 3, if I compare them, are they equal? Python is telling me that it is false. Okay. 3 equals 3. Are they equal? This is true. Okay. So similar to this python.org website, we have this Anaconda here. So from Anaconda, you can download here the Anaconda and install in your machine. You can also use this start coding now, and using this start coding, you can go to this Anaconda cloud here. It will ask you to create a free account first, and then once you create the account, you can sign in from here. Once you sign in, this Anaconda nucleus will open. It has a large body of help here, lots of tutorials here, particularly for machine learning related applications. And then here you can see at the top there is this notebook, so you can click this notebook and open up this notebook here. It will take some time to run the server depending upon your internet connection. It may take a while. So you can see that Jupyter Lab is opening up. So we are here. You can open up a notebook from here. So this is an IPython notebook, and you can write your code over here. Similar to this, there is Miniconda. This is a minimalistic version of Anaconda. Depending upon your operating system, you can download the necessary Miniconda here and you can install. After your installation, it will give you a command prompt. From that command prompt, you can run Jupyter Lab or any other IDEs such as Spider also you can run from that command prompt. Any package you want, you can install from that command prompt. Similar to this, here you see the Google Colab, and from here you have file and you can open up a new notebook. So a Jupyter notebook is opened up over here. You can write your code here and then run by clicking this icon. I hope you are now ready for your first Python program. If you are thinking what to do, my suggestion is just to install Anaconda and open Jupyter Lab from there. If you have problem in installation, use online help. From your Jupyter lab, open Python notebook and write the following code. Print first bracket, and within first bracket write hello world. Hello world should be within quote, single or double quote. Now you hit shift and enter keys together. You should see the results to appear on screen. Hello world. Let us check it for ourselves. Here I have used my mkdas command prompt and opened up a Jupyter notebook from there. From here you can see that there is this IPython kernel, and if I click this, I can open up an Python notebook from here. You can see that this is an untitled notebook, and so I can give a name here. Now I can write the code here. So for instance, print hello world here. You can see that this is a code window. In Jupyter notebook, you can have code window, and then you have markdown or raw window. So you can write code here in the code window. Right now we are in code window. So I have written this small one-line Python code. I can run it now using shift plus enter, and you can see that it is writing hello world. I can define certain variable, for instance a, which is equal to this hello world. So a is a variable and it is representing a string here, and I can then write print a, and then again with shift and enter it will give me the same hello world. So what is a? I know that from here this is type a, and shift enter gives me str, that is string. So a is a string. A itself doesn't have a type, but this hello world does have a type. So for instance, I can assign a equals 2, and then I write type a and shift enter. It gives me int. That means it is saying that a is an integer. So a itself doesn't have a value. Whatever is contained within a, that is the type a. You can save this notebook from here, from the folder where you have opened it up. It will save this hello world.ipynb in that particular folder. Hello world is a type of data we call string in Python. String in Python is a sequence of characters. We use strings for various purposes, such as writing in screen or naming a variable. Strings are written within single or double quote. Print is a Python function. Functions are important objects in Python. Like mathematical functions, Python functions take some inputs and gives back one or more outputs. The inputs in Python function are written within first bracket. A is a variable. Variable is a Python object that holds some value. In this case, a is holding a string hello world. Variable itself does not have a type. However, the value it holds does have a type. In this case, variable a is holding hello world, and hello world is of string data type. You have already seen the Python print function in action. The function takes inputs within the first bracket and then delivers the output, which is same as the input on screen. The space between the word print and the first bracket doesn't matter. The word print is also what we call is a Python keyword. Python keywords are words that are reserved by Python for specific purpose. They are part of Python syntax, and thus we, the Python programmers, cannot redefine them for use for any purpose other than what is already specified to them. We cannot name a variable or user-defined functions using the keyword. Python has many keywords such as and, or, if, else, and many others. So in Python, how do we name variables then? We follow few simple rules. Rule number 1 is, of course, as we have already known, not to use keyword. Variable names contain letters, digits, and underscore. The name, however, cannot start with a digit. It is possible to start the name with underscores. However, such variables serve special purpose in Python. We don't want to discuss that now. In short, best not to start name with underscores unless you know what you are doing. Finally, the most important part, that is the Python names, unlike many other languages, are case sensitive. Now to summarize this session, we have learned how to use Python in local machine as well as in cloud. We have written our first code, that is the Hello World code in Python. We now have some familiarity with Python string data type, variable, function, and keywords. Large number of Python books and web resources are available. You may visit this Python wiki and read some books such as Python 3 Standard Library by Hellman. As your exercise, please go online and find 5 more Python keywords beyond what we have listed in this lecture. Also try to add strings and multiply strings with scalars and see what happens. Thank you, and that's all for now.